Hello everybody, in this tutorial I will demonstrate the use of staging, time-dependent consolidation and multiple material in Settle 3D. The model represents a storage tank that is built on layered soil and filled with water. The model will consist of a total 13 stages that will represent varying loading as the stage tank is filled or emptied. So the topics that we will cover in this video is load staging, embankments, multiple materials, time-dependent consolidation analysis, and finally immediate and consolidation settlement. So first step to create the model, as always, we go to analysis to define the project settings. So let's keep the stress computation method as a Bosanisk, and then we make sure the stress in metric, kilopascal, the settlements in meters, and since we're gonna do time-dependent consolidation, so we need to activate this. He's asking us about the analysis. The analysis option will be turned on. Yes, okay. Click on OK. Make sure time units in days and permeability units is meter per days. You may have it as meter per year, so make sure this is meter per day. We click on OK. The next stage or the next step actually is to define the stages. As I mentioned before, I'm going to make 13 different stages. So we go analysis, project settings, and choose a second tab here as stages, and choose, you can enter it 13 or you can increase it to 13 from the number of stages. So now we're going to go to the first stage and define the time. Here at the first stage, initial stage is going to be 0. The second stage, we're going to enter 30 days. Third, 150. After this stage, we're gonna go, actually, I forgot to change the groundwater, so we go back to the same window and we go to the groundwater. Make sure that the groundwater analysis is activated. Keep the water unit as it is, 9.81 kilonewton per cubic meter. And then at the depth of water table, we're gonna change it from 0 to 2 meter. And then we go to the project summary. You can enter the title of the project here. So I'm gonna enter the title as storage tank. You can name it anything. Then I'm gonna click on OK. So now the next step is to add the embankment. So I'm gonna go to loads, and then you're gonna see that you can add the embankment by clicking on add embankment, or you can do a shortcut as a Control+6. So click on that. Here you're gonna have the embankment designer window. So let's change the base width to 200 meter. Okay, and then we're gonna change the near end angle and far end angles to 8 degrees. Good. Now we're gonna change the left angle, both left and right angle actually, to 8. And the height of the embankment should be 7. We're gonna change it to 7. And then that's it. As you can see here, we have now a new geometry of the embankment. So you can, anything you enter it here, you're gonna see in the immediate change above in this below window here. Okay, so now we're gonna click on OK. So now the software is asking us pick here, as you can see, pick the near point of the embankment center line. So instead of use mouse to enter that near point, we're gonna enter in this here in this window. I'm gonna enter 0 and minus 125, 125, minus 125. So this is the first point, as you can see here. Now we define the first point on the left window. Now we need to define the second point. So I'm going to define it as 0, comma 125, and then click enter. Nice. So we have our embankment, as you can see here, with height. The height of the embankment is about 7 meters. Okay. The next stage is going to be defining the load. So we're going to add staging load. So we go to loading tab here, and the tank is like a circular tank, so I'm going to add circular load here. So the storage tank actually will be modeled in this video as a circular load. So we click on the circular load, and then we have this window asking about the circle radius and the pressure. For the radius, we're gonna make the radius of the tank is 32.5 meter, and the pressure is 230 kilopascal. So here the depth. Actually, we're gonna display advanced staging to show the depth. Remember, in Sector 3D, minus means below. Minus means above the ground surface. Positive means below the ground surface. So we're gonna enter minus 7. Remember, the embankment height is 7. So if you want the tank to be on the top of the embankment, we should enter minus 7. Minus 7 for the second load effectively places the load on the top of the embankment. Remember that the depth is positive always in Sector 3D. Positive downward. Therefore, negative depth is actually above the ground surface. So we're gonna enter here minus 7 for all stages. The load factor, since we have 13 different stages, so we're gonna build the tanks at different time with these different load factors. The first stage is gonna be 0.109. Okay, now we click on OK. So the software is asking us to define the X and Y coordinates of the load locations. So in this tutorial, we're gonna enter 0, 0, the coordinates of X, Y, and for the tank, which is the center of the tank, and then click OK, click enter. So you can see now the tank is on the top of the embankment. So if we go side view here, you can see it's exactly on the top of the embankment. The height of the embankment is 7 meters, and we define the depth of the tank as -7. So now it's exactly on the top of the embankment. You can change the coordinates or the load by right-click on the tank, and then you can choose the load properties, and then you can, if you made mistakes, you can go back to this window and edit the load. And also you can actually edit the coordinates as well. Okay. By the way, you can look through the various stages by selecting the tab at the bottom of the screen here. This circle load should be changing as you go through the various stages. So for example, here now at 0 days, as you can see, it's like very, very small. If we go to 460 days, it's going up. So that's what I meant by changing the stages. So you can see that we are building the tank on the top of the embankment. The last day is at 1,530 days. So this is what you should see in your model, changing the load by when we choose different stages or different dates. Okay. If you cannot see this changing, that means you made mistake in the load staging. So you need to go back and modify the staging, loading stages. Okay, so now we define the embankment, we define the tank. Now, if you want to define the soil properties, you need to go to the soil properties. And properties, click on soil properties, or you can click on Control 8 and a shortcut. Okay. By the way, I forgot to mention the depth of bedrock. So as you can see here, before we go to the properties, the 3D view shows a soil layer with the default thickness of 20 meters. The thickness, the layer that we have is just one single layer, and the thickness of this layer is 20 meters. You can see the depth here. And it's assumed that the rigid bedrock lies immediately below the soil layer. So the bedrock depth is here actually at 20 meters. Okay. We will learn how to change the soil properties and layer geometry, and define different soil properties for each layer. So we go to soil properties, click on this. Now we're gonna define our first layer. So we're gonna name the first layer as sandfill. Okay. And we're gonna activate for each of the first 3 materials, we're gonna turn on the immediate settlement and change the primary consideration material type to linear. And then this is for the three first layers. And we're gonna change the E sub S, the elastic modulus here, to 25,000 for the sand fill, and the E sub SUR to 25,000, same, and C sub V, gonna change it to 0.25. So if you're not sure, if you don't have enough lab data, you can choose, actually you have different values for C sub V. Usually we get this value from consolidation test at the lab, but if you don't have, and if you're not able to do this test and you know the material is like sand or silt or clay, you can actually search approximate value, or here we have a lot of ranges based on the material that we have. So if you already characterize the material and you already know what you have in this layer, you can choose any numbers from these ranges that the software is provided. So in this case we have sand, so you click on the sand, actually, so usually sand we cannot do consolidation, we cannot like we can calculate S sub V, but here in this software we know we don't have values for C sub V, so we have value for clay, for silt, maybe plastic silt, but we don't have anything for sand. But you can do some correlation to estimate C sub V. Okay, so now we go to the second layer. I'm gonna change the name to silty sand, and activate the immediate settlement. Now we're gonna change the E sub S to 20,000 and E sub SUR to 20,000. And C sub V, make sure this is linear also, we're gonna make it linear. Keep MV as it is, this is the volumetric compressibility. I think we can also estimate this if we click on this list. We can get some idea about the values for any kind of material we have. Also, we can get this parameters from consolidation test. For C sub V, we gotta change it to 0.25. Then we go to the third material. The third material, I'm gonna call it dense silty sand. You can change the colors, you can add hatch if you want. The unit weight, I'm gonna keep it as it is. Activate the immediate settlement and then change this to 25,000 for both. And then change C sub V to 2. And the fourth material, change the name to silty clay. Turn on the immediate settlement, and ES and ESCOR we're gonna enter as 9,000. Ensure the material type is non-linear, so in this case we're gonna leave it as a default. Change the C sub C to 0.38 and C sub R to 0.01, and over consolidation ratio we're gonna change it to 0.7. Initial void ratio we're gonna change it to 1.1, or default is 1.1, so we're gonna keep it. Change C sub V to 0.05 and and same thing for C sub VR. Leave all other parameters as their default values and then click OK to exit the dialog. So now we defined 4 different materials, but we haven't assigned these materials to our models yet. So the next step is going to be assigning these material that we already defined in the previous stage to this model. So click on Insert Layer below. So actually to define, let's define the thickness first. So go to Soil Layer. And we're going to define 4 the 4 materials that we already defined to our model. So we're going to insert below. So the first thickness is going to be 2 meters, the second 8, third is 20, the last one is 50. Here it says drained at the bottom. So we're going to activate last 2 layers, so they're going to be drained at the bottom. And here, as you can see, there is drained ground surface. So this is already activated. So at the surface, we will assume that there is drained, the material on the surface is going to drain on the surface, and the last 2 layers, they're going to drain at the bottom. Okay. Then click OK to close the dialog. So now, as you can see, we have 4 different materials. We have the first one, the thickness is 2 meters. And as you just hover over it, you can see the thickness 2 meters, the second is 8 meters, the third is 20, and the last one is 50 meters. So now we assigned the properties of the material that we already defined in the previous stage into our models. Okay. Now we need to define the grid to start the analysis. So go to select auto fill point from the toolbar on the grid, and then change this to 500. And auto grid expansion factor, make it 1.2. And then click on OK. It's going to take a little bit of time. Grid will be generated and stress and settlement will be automatically computed throughout the 3-dimensional volume. This will take a little time depending on the speed of your computer, of course, but by default, actually, the contours of total settlement will be shown. You can change from total settlement to vertical stress to effective vertical stress as you wish. So we will see how it's going to look like in a few seconds, maybe. So now that's last stage 13. So now you can see the total settlement, which is here in our case, the maximum is 4.2 meters approximately. This is at the last stage. Okay. Yes. In the third stage, on the stage number 12, the maximum settlement is gonna be, it's like 4 meters. At stage 9, at 850 days, the settlement is 3.6. Okay. So you can see the settlements with these contour lines at different stages. So we can change the total settlements to show the data in terms of consolidation settlements. The total consolidation settlement is 2 meters. As you know that consolidation settlement plus the immediate settlements and secondary settlements is equal to the total settlement. So also we can see the effective, the excess bore water pressure, of course, and the effective stress, etc. Okay, so now we're gonna see how to plot these and see if they make sense or not. So on the toolbar at the top, you can change the data type being plotted. So I'm gonna first actually, I'm gonna add like from Curie, I can add Curie Line as keep it as a default and then click on OK. So it's asking pick the first point on the line Curie. I'm gonna click on the center of the tank here all the way out. Then right click, and here we have 4.31 meters, and on the side we have 0.5, excuse me. So you can see now the settlements. We can plot these settlements. If we go to Curie, graph Curie, click on this, then right click, done selection. We can select all stages if you want to see the settlement versus depth at all the stages. Click on OK, close. And now you can see the total settlements from stage 1 to stage all the way to stage 13. And of course, the highest settlement will be at the center of the tank, equal to 14.6 or 4.3 meters. You can close this window from here to go back to our models. We can also show the stages versus days. So we go back to the Curie, graph Curie, click on this point, right click, done selection, and look for I guess I don't have it here. But we can do this. Yeah, we can show the excess bore water pressure. Hello again, sorry, I just paused the video to figure out how to plot the settlement at different stage. So now I know how to plot it. So first you need to actually, you need to go to Curie and add Curie point at the center of the tanks or anywhere you are interested in. Then go to Curie back again, click on the graph Curie, click on the Curie point that you just assigned, right click, done selection, and now from here you can go and change the plot type to data versus stage time, and then you can choose anything from here. I'm gonna choose the total settlement, and also you can choose the depth and then click OK. So now you see that at the first stage at time 0 we have this settlement, and at the last time or the last stage we have this amount of settlements. If you want to go back to the model window, you click here, or you close this window from here. So this is, I hope this tutorial is like you enjoy it and you learned from it. Please share this video and like if you like it, and subscribe to the channel. Thank you.